Geometry 9.3, Relationships with Inscribed Angles and Intercepted Arcs. Go ahead and get started with the warm-up. One thing you might want to realize is that you can actually draw another radius in from A to C, which, remember, that makes a right angle. All right, so now you have the three angles in a triangle. So the central angle would be 60. And then the arc is also 60. All right, then to review, the central angle, remember, that's the angle that meets up at the center. That's going to be the same as the intercepted arc. Or the inscribed angle, that is the angle that goes all the way across the circle, and that's called the inscribed angle. Okay, tangent line. To review, that is the line that just touches the circle one time. And remember, when a tangent line connects with a radius, it's going to make a right angle mark. Okay, this one is a new one this time. A secant line. This is a line in the plane that intersects the circle at 2 points. So it looks like a chord, but the difference is this is a line. So it's going to keep on going forever and ever and not just stop at the edge of a circle like a chord does. All right, next, inscribed angle conjecture. The measure of the angle inscribed in the circle is half the measure of the intercepted arc. So if the arc was 80, that central angle would be 80. The inscribed angle that's going across the circle is only going to be 40. Half as much. Okay. All right, the inscribed angles intercepting arcs conjecture says that if you have inscribed angles intercepting the same arc, then they are congruent. All right, so let's look at an example of this. So if we have this angle here, going with that arc, and maybe we can say that arc's 100 degrees, so then this angle would be 50 degrees. Let's write some numbers in there. All right, and then we have another arc that goes with that same 100-degree angle. So another angle that goes with the arc. So this angle is still going with that 100 degrees. So then this angle down here would be 50 as well. So then these two angles are going to be congruent. All right, next one, inscribed angles in a semicircle says that if you have angles inscribed in a semicircle, they are always going to be right angles. All right, so in order to have a semicircle, remember you have to have the diameter, and then from there we can use that semicircle as the arc. And then make an angle out of it. So since a semicircle is 180 degrees, then the arc across from it would be half as much. So half of 180 would be 90. So then you can go ahead and add that right angle box in there. All right, the cyclic quadrilateral conjecture says the opposite angles of a cyclic quadrilateral are supplementary. So if we draw a quadrilateral, cyclic just means that each edge touches each vertex of the quadrilateral touches the circle. So there we go. That would be an example. So then the angles that are across from each other are supplementary. So if we call this A, and then we've got B, C, and D, think about which two should add up to be 180. So A plus C would equal 180 degrees, and then B plus D would equal 180 degrees. All right, next up, parallel lines intercepted arc conjecture. The parallel lines intercept congruent arcs on a circle. So if you have these two lines that are parallel to each other, remember that means they never cross, then the arcs that they go with are going to be congruent. So arc BC is congruent to arc DE. All right, let's go ahead and look at a couple examples below. So example 1 says find the measure of arc AB, and then also what is X. All right, so the measure of arc AB, remember, since we're given that central angle as 60 degrees, then arc AB would also be 60 degrees. All right, and then since the arc is 60, the inscribed angle going all the way across, so to figure out what X is, should be 30 degrees. All right, let's go ahead and take a look at the next one. We are trying to find the measure of angle ACB. Remember that ACB should be angle C there. It's the middle letter. So because it is across from this semicircle and it's the inscribed angle, we can take 180 divided by 2, which is always going to be 90. So that's going to make that right angle mark. So we would know that the measure of angle ACB was 90. Okay, then the next one, the measure of angle BAC. So now you have a triangle, so you can figure out what degree that is. And finally, when we want to find that last one, the measure of arc AC, use the idea that the intercepted arc is twice as big as the inscribed angle. So if you can try to find the angle that goes with AC, if you extend it, it's going to look like this. And so since I know the angle is 55, now I could find the measure of arc AC. So let's go ahead and work on those two, pause the video, and then try example 3 as well. All right, so example 2, to finish this up, angle BAC, if we subtract from 180, since it made a triangle, 90 and 55, we would be left with 35 degrees. Measure of arc AC is twice as big as the inscribed angle, 55. So we just need to take it times 2 to get 110. Then if we look at that last problem, example 3, since both these angles, ACB, which would be this angle right here, and then ADB, go with the same arc of 124 degrees, they are both just cut in half. So that's half of 124 and another half of 124, so each of them are 62 degrees. Okay, go ahead and try example 4. You can pause the video, try that example, and then come back when you have it done. All right, if you had a chance to finish up example 4, there's what the answers should be. And then you can go ahead and get started with the assignment. Assignment is the next 2 pages, 9.3. All right, if any of the notes went too fast, the video will be posted online. You can also look at the notes online, the answers of the notes if you didn't catch some of those. All right, so go ahead and work on page 19 and 20.